Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 7 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3341. Find minimum time to reach last room 1. So let's read the problem statement first. There is a dungeon with n into m rooms arranged as a grid. You are given a 2D array move time of size n into m, where move time ij represents the minimum time in seconds when you can start moving to that room. Okay, you start from the room 00 at time t is equal to 0 and can move to an adjacent room. Moving between adjacent rooms takes exactly 1 second. Okay, but there is one wait time also given to us here, right? All right, we have to return the minimum time to reach the room n minus 1 and m minus 1. Okay, two rooms are adjacent if they share a common wall either horizontally or vertically. Okay, so let's understand this problem statement with an example here. Okay, so this is move time array given to us, right? 2D array. Okay, so in this move time, okay, so this is 2D array, right? So here I can draw it like this. Okay, this is done, and here this and this. Okay, so now this is 2D array, right, of size n into m. Okay, so n is 2 here and m is also 2 here, right? Okay, 1 2 and here 1 2. Okay, so 2 into 2 array, right? So here this is nothing but my 2 into 2. Okay, grid I can say, right? All right, okay, or matrix, whatever you want to say. And here if I just give the indexing 0 1 and 0 and here 1. Okay, and here see, this is value at 0 0, right? So at 0 and 0 we have this value 0. Okay, and at 0 1 we have value 4. At 1 0 we have value 4, and at 1 1 we have value 4. Okay, so this 0 is nothing but the wait time for room A, let's say. This 4 is nothing but the wait time for room B. This 4 is nothing but the wait time for room C, and this D is equal to 4. That simply means the wait time for room D, right? Okay, so now here it is saying that we are always going to start from 0 to 0. Okay, 0 to 0 always we have to start, and we are going to start at 0 time. Okay, we are going to start at 0 time. Okay, and we have to reach where n minus 1 m minus 1. Okay, so we have to reach here 1 comma 1. Okay, so here what I'm saying, we are going to start from this. Okay, we are going to start from this. This is nothing but my source, and this is going to be my destination. All right, okay, so, and we are always going to start from here. Okay, at time, let's say 0. Okay, at time 0. Okay, so here it is given, right? You start from the room 0 0 at time t is equal to 0. Okay, and let's say the time of all these rooms are infinity right now. Okay, this is infinity in box. Okay, this is also infinity, and this is also infinity right now. Okay, in the box I'm writing. Okay, all right, so this is done, right? So we have to start moving from here and we have to reach here. Okay, so this is my source and this is my destination. Okay, so here we can simply apply our disastrous algorithm, right? So what is this disastrous algorithm? Okay, since we have to find the minimum time to reach the room. Okay, so Dijkstra algorithm says that it is nothing but a classic shortest path algorithm which is used to find the minimum distance from a source node to all other nodes in the graph. Okay, but we have to only reach here, right? Okay, with non-negative edge weights. All right, so now why we are going to apply Dijkstra? So here see, take each room. Okay, A room, B room, C room, D room. Take each room as a node. Okay, and we are going to move to the adjacent rooms. Okay, with an edge weight of 1 second. Okay, so we can say edge weight of 1, right? So here see, from this room you have these many options, right? Adjacent rooms, you can move to this side, you can move to this side, you can move to this side, you can move to this side. Okay, from here you can't move here, but okay, in between if there is any room, so we have four possibilities, right? We can move up, we can move to down direction, we can move to the right direction, we can move to the left direction. Okay, so here for this particular room A, we can't move up, we can't move to left side, but we can move here B and C, right? Okay, so here each room we are going to consider as a node. Okay, and we are going to move, take the movement to the adjacent rooms in an edge with weight 1. Okay, 1 second, right? You can however you can only enter a room after this value. Okay, move time of ij value. Okay, so each edge has a dynamic delay as well. Okay, okay, so you are always going to process the least time cost path next. Okay, just like disasters here, right? So here let's understand what we need to do. Okay, but before that, here uh, uh, let's consider you are here at 0 comma 0. Okay, let's say, all right, and now if you want to move up, okay, so that simply means what I'm saying, from this row you are moving up. Okay, so here I can say now, I can write it like this, -1 comma 0 this side. Okay, we are only decrementing this row part. Okay, column is remaining same. Okay, 0 here, 0 here, but we are decrementing the row. Okay, from 1 to 0. Okay, so 0 here I'm writing -1. Okay, so this is nothing but my up direction. All right, now same way, if you want to write your down direction, okay, that simply means you are moving from, let's say, here 0 to 1. Okay, so here you are incrementing the row, right? So here you can say 1 comma 0. Okay, so this is nothing but the coordinate for the down direction. Okay, this is done. Now if you move to the right side, okay, so here what you are incrementing, you are incrementing the column part. Okay, so here this row is going to remain same, but column is, you are going to write 1. Okay, so this is nothing but the right coordinate. All right, now if you are moving from here to here, 1 to 0, so you are decrementing the column, right? So row is going to remain same, but column is value is decremented, so you are going to write this like this. Okay, so now just this is nothing but your upper direction. Okay, this is nothing but your right direction, this is nothing but your right down direction, this is nothing but your left direction. Okay, so if you are at this particular cell, okay, and I ask you to move to the left side. Okay, so what you are going to do, so in this 0 you are going to add 0. Okay, you are going to get 0 only, and in this 0 you are going to add -1, so you are going to get -1 only. So see, you are moving to 0 -1. Okay, right? Now let's suppose you are at 0 comma -1. Okay, let's suppose you are at 0 comma -1. Okay, all right, so let's leave this example. Let's say you are here. Okay, you are here at this is nothing but 1 comma 1. Okay, now from here if I ask you guys to move to the left direction, okay, to the left direction, to here, from D move to C. Okay, so what you need to do, you have to just add this 0 and -1. Okay, so here if you add 0, so you are going to get 1 only, and here if you are going to add -1, so 1 plus -1 you are going to get 0. Okay, so 1 comma 0. So see, this is nothing but 1 comma 0 only. Okay, so you have to just add these values. For left, if you are moving to left, just add this. If you are moving to the up direction, just add this. If you are moving to right, add this. If you are moving down, add this. Okay, that's it. Okay, this is very simple, right? So now here what you need to do, all right, so here this take one time. Okay, time array, and initially we are starting from here now, so here just set the time of this to 0, and all set other one to infinity. Okay, since we have to reach from source to destination, okay, in the minimum time, this is what we need to do. Okay, and right now we haven't visited anything. Okay, so here I can say unvisited, this is also unvisited, unvisited. Okay, unvisited. Okay, we haven't visited anything. Okay, so now here start from here, start from here. So from here you cannot move to this direction, you can't move to this direction. Okay, so take one priority queue. Okay, in priority queue, first here just add, right now you are at row 0 column 0 and at time 0 seconds. Okay, this is nothing but time, this is nothing but your x value. Okay, x coordinate, you can say row, and this is nothing but your y coordinate. All right, right now, so we have to run one loop. Okay, we have to run one while loop. Okay, this is initial setup. Okay, here I'm taking one priority queue. Okay, so now after that you have to run one while loop, and in the while loop you have to run this until my priority queue is not empty. Okay, priority queue is not empty. Until then you have to run this. Okay, so right now it is not empty. Okay, my priority queue. Okay, so these are the values, right? So now what we have here, we have current time is equal to 0. Okay, we have current x value is equal to 0 and current y value is equal to 0. Okay, so now here after that check the neighbors of this. Okay, check the neighbors of this. So here you can't move to this direction. Okay, if you add here in 0 0, if you add 0 minus 1, you are going to move to left. You can't move here, you can't move up direction, but you can move here in this direction. Okay, so if you are moving in this direction here, okay, so you are going to here to move to this cell. Okay, so wait time is 4 given to us, right? Wait time is given to us as 4. Okay, so we can move to this direction. Okay, but here wait time is there, right? So here how you are going to calculate the wait time? So you are going to calculate the wait time like this. Okay, wait time is equal to math dot max of. Okay, so here current time, so current time is 0 right now. Okay, current time is 0. Okay, current time, so here current time, which is nothing but 0. Okay, and here this is nothing but current time. Okay, current time is 0, right? And here move time. Okay, move time, and here you have to pass the new coordinates nx and ny. Okay, so if you are moving to this direction, so your nx is going to be 0, nx is going to be 0, and ny is going to be in this direction you are moving now, so it is going to be 1. Okay, so how we are going to get this? You are moving to the right direction. Okay, so in this 0 you have to add for right 0, so you are going to get 0 only. Okay, so this is nothing but your new x coordinate, and here in 0 if you add this 1, so you are going to get 0 1, and you are going to get 1, so this is nothing but your new y coordinate. Okay, so this is how. So here move time new x new y. Okay, so move time 0 comma 1. Okay, move time 0 comma 1. Okay, so move time 0 comma 1. So here move time 0 comma 1, here see value is 4. Okay, so this is nothing but the wait time. So this 4 is max or current time is 0? What is max? So 4 is max, right? So your wait time is this 4. Okay, wait time is 4. And also here next time we have to calculate, right? Next time, right? So here since moving from this to this adjacent cell is also going to take 1 second. Okay, it is also going to take 1 second. So here I am just going to add the next time as, okay, next time as 5. Okay, this is my next time. Okay, so here what I'm doing, so from here to here I am moving. Okay, so here wait time is 4. Okay, so if once I reach here 4, then next time what I'm going to consider is 5. Okay, okay, so now you have to just add this to your priority queue. Okay, add this. So now you are at your priority queue is right now empty. Okay, you have already visiting this. Okay, 0 0 0. Okay, so just mark this as visited also. Okay, you are checking its neighbor, right? So here this is one neighbor, and also we need to check this one as well. Okay, so if you have already checked this. Okay, so for this in the priority queue you have to add what the next time is going to be 5. Okay, and after that here you have to pass the coordinate. Okay, new x and new y 0 comma 1, 0 comma 1. All right, so this is what you need to pass. Okay, and here we can do one thing. We can maintain this priority queue based on this time. Okay, so we will keep this to the top. Okay, right? So we are going to use min heap here, right? The time with minimum this value, okay, will come to the top. Okay, so we are going to use min heap, okay, based on this first value, right? So this is done. Now same way move here. Okay, check this. So in this also you see wait time is 4. Okay, so from 0 only we are moving. Okay, so here also same you have to apply this. Okay, current time is 0, right? From this only we are moving to this, right? So 0, and new x is going to be this time 1. This is going to be 1 this time, and your new y is going to be 0 or 1 only, 0 only, right? New y is good 0. Okay, so now here you have to apply the same thing, right? Here 1, and here it will be 0. okay, and add new x 104 only, so you are going to get 4 only, and the next time is going to be 5. Okay, so 5 only you have to pass, right? So here you can write 5 here, okay, and the coordinates 1 comma 0, okay, new x 1 comma 0. All right, so this is done. Okay, so this is done. So you have marked this wasted. Okay, so now this is wasted. Now from here you can pick anyone. Okay, so you can pick this top one first. Okay, just call this 5 1 comma 0. All right, 5. So current time is 5. Okay, current time is 5, and x coordinate is 1, and y coordinate is 0. Okay, so just remove this also. Okay, done. Okay, so here also from here na 1 comma 0, you are visiting this 5 1 comma 0. Okay, so this one. Okay, so from here you can't move to this direction because this is already visited. Okay, but you can move here. This is the only option, right? You can move to this direction. All right, so this is nothing but 1 1 coordinate. Okay, so new x is going to be 1 and new y is going to be 1. Okay, others are not valid, so we are not going to check. Okay, so here this is what you need, right? Now here just calculate the wait time. So for this wait time is 4, but my current time is 5. Okay, so we have to take the bigger one only, so I'm going to consider this only. Okay, so my wait time is going to be 5 only. Okay, so we apply this formula, wait time is going to come out as 5 only, because it is 4, right? And we have already crossed this, right? 5, so we can easily reach out there, right? So now this is there. Okay, and this wait time is 5. Okay, so here initially the value was set to infinity. Okay, so uh here change it to 5. Okay, we can reach here in 5. All right, we can reach here in 5. Okay, we have to update it in 5, and here also we can reach in 5. Okay, right? Now here, see, from here you are moving, and here the time is infinity right now, infinity. Okay, and new time that I'm getting here, wait time is 5. Okay, and next time is 6. Okay, wait time is 5, and next time is 6. Okay, so I'm getting 6, right? So we can easily reach out here in 6, right? We can easily reach out here in 6. 6 is smaller than infinity, so definitely we are going to update this. Okay, so we are going to keep the minimum time only, right? So here I'm writing 6. All right, and now in the priority queue, what I'm going to add, I'm going to add the next time 6, and 6 is going to come here in bottom, and this is nothing but 1 1. Okay, 1 comma 1. Now next time. Okay, so this is done. From here, from this side you are visiting this now, so mark it as visited as well. So here I am marking it as visited. All right, so this is also visited, so two cells are visited. Now from here you have to check. Okay, so from here also you can go to that particular, right? So here 5 is the current time. Okay, and your x coordinate is 0, and y coordinate is 1, and your new x is going to be 1 only, and new y is going to be 1 only. Okay, because from here you are only moving to this down direction, right? Okay, so now here again wait time is equal to this current time, which is 5, and move time here new x 1 comma 1. Okay, so at there we have just 4, right? But my current time is 5, so I'm going to take this as my wait time value, and next time I will take as wait time plus 1. Okay, 6, right? So this 6. Okay, so now here see, this value is already 6. Okay, now I am taking again 6 here to reach it, so I don't need to update my priority queue. Okay, no need to update. All right, so this is done. Okay, since we are already moving in 6, the 6 at that particular room. Okay, in this particular room we are only reaching in 6. Okay, in the past, so again I am reaching in 6, so no sense, right? So we'll take minimum only, right? So now next time you are going to check this. Okay, and also make sure to mark it as visited, this one, right? So now this is done. So now this is left, and this is your target only, right? So here just come out here. So here your current time is 6, and your x value is 1, and y is value 1. Okay, but you can't visit anywhere. Okay, this is your final target. Okay, this is wasted, this is wasted, we can't move here, we can't move here. So that's it. Okay, your priority queue becomes empty, and in the end you have to just simply return whatever the value that is stored here. So here we have 6, so we are just going to return this 6. That's it. Okay, so simple. So this is the same thing that we have to write in the code, right? So now let's move to the coding part. So whatever I've explained, okay, I'm going to write the same things here. Okay, so here first calculate the value of n, move time dot length, and then calculate the value of m is equal to move time. Take one particular row, okay, and just calculate the length. Okay, this is going to give me the length of column, right? And then calculate, just create one 2D time array, right? And I'm going to set all the values to infinity. Okay, initially what we are doing here, we are setting all these to infinity. Okay, time period in the box. Okay, I will write infinity, infinity, infinity everywhere, right? So here int time is equal to new int, and here inside this you have to just write n and m. Okay, this is done. Then after that you have to just iterate over all the rows one by one, right? Int row in the time, okay, and I'm going to fill them with the max value of integer. Okay, so here I'm just going to write arrays, a should be capital, arrays dot fill row with integer dot max underscore value. Done. Now once this is done, then after that what you need to do here, uh, the value at cell 0 comma 0. Okay, so we are at source only, so just change this to 0 from infinity. Okay, so here I'm just going to write time 0 comma 0. Okay, and I'm going to set it to 0 only, right? So this is done. Now we have to create one priority queue. Okay, priority queue, and after that inside this int, okay, and here pq is equal to new priority queue, right? And here you need min heap, right? So here based on the first value, so here you can use this comparator. Okay, comparator dot int comparing int, and here from this a based on, okay, a of 0 value. Okay, right? So this is what we need to do here, right? And now once this is done, then in the priority queue you have to offer first, you are at time 0, row x is equal to 0, and your column is 0. Okay, row is 0, column is 0, and time is 0. So here what you need to do, pq dot offer, and after that here you have to write new int. Okay, and here inside this you have to pass 0 comma 0 comma 0, right? So here you can say this is nothing but your time, row, and column. Okay, this is done, right? So now after that you have to pass the directions as well. So int directions, okay, is equal to, so here you have to write, so I have already explained how we are getting directions, right? Minus 1 comma 0, right? And then you can say 1 comma 0. Okay, 1 comma 0, then there is one direction you are going to take as 0 comma minus 1. All right, okay, and then after this 0 comma minus 1 you have to take one more direction. One second, this is done, and here you have to take 0 comma 1, right? So 0 comma 1. All right, so these are the directions. All right, so now here let me write a comment as well. Up, then next is for down, then next is for left, and then next is for right. Okay, so this is done, right? So now after that create one boolean visited array as well, right? So here boolean visited is equal to new boolean, and here n, and here m. Okay, now once this is done, then it's very simple. Okay, you have to just run one while loop, that's it. Okay, so here while your priority queue is not empty, is not empty. Okay, so now here inside this you have to write the current value. Okay, so current is nothing but just all the top element from the priority queue. Okay, so pq dot all, done, and then take the current time as cur time is equal to cur of 0, right? And take x value as cur of 1. Okay, and take y value as cur of 2, right? We are passing total three positions, right? First is time, second is row, and third is column. Okay, that's fine. Now this is done. Now here just check if we have already visited that particular cell, then we don't have to visit it again. Okay, then we don't need to visit that again. So here visited of x, y. Okay, in that case just continue. All right, and otherwise just mark this as visited. Okay, visited x and y, just mark it true, and we are going to visit all its neighbor now. okay, after this. Okay, so now here how to visit the neighbors. So simple, it run one for each loop. Okay, and we have to check in all the directions. Okay, int d in directions. Okay, and here after this, what is your new x value? So new x value is equal to x plus d of 0, right? X plus d of 0, this is your new x value, and your new y value is nothing but y plus d of 1. Okay, so this is your new y value, right? New x and new y coordinates, right? Now you have to check if these are valid or not. Okay, here you are going to check if your nx value, it should be greater than equal to 0, and nx value, it should be less than your n. Okay, same way, and your ny value, it should be less greater than equal to 0, and your ny value, it should be less than n. Okay, these three things, just these three four things, just make validate it. Okay, and now you must wait until the move time of nx and y before moving. Okay, so you have to wait until then. Okay, so wait time, int wait time is equal to math dot max of current time, right? And here move time. Okay, move time at this particular coordinate. Okay, new x coordinate and new y coordinate. Done. Okay, and the next time is going to be next time. Next time, okay, you are wait until then. Okay, and then you are promote, so you have to add one as well, right? So here wait time plus 1. Okay, so this is done. Now here only we have to update the timing when we are reaching in the minimum time. Okay, if it is 6 here and from here also we are reaching in 6, then we don't need to update. But if here it was infinity and from here I'm reaching in 6, okay, minimum time, then we have to update this to 6, and then only we have to add that into priority queue. That's it. Okay, so just 2-3 times pending, and that's it. Okay, so here if next time, okay, whatever the next time, if it is less than the original time value, okay, add this new x and new y. All right, so in that case only you have to update your time nx and ny, okay, with the next time, right? And then after this only you have to poll this to the priority queue. Okay, so in your priority queue dot offer, and what you are going to add, so here new int, and here now you have to pass next time and the new x coordinate and new y coordinate. That's it. Okay, and in the end just simply return what the last cell, right? The time at last cell, return time at n minus 1, and here you can write m minus 1. That's it. It should be less than m na. Okay, m, right? So let's run it, n into m, right? So in this side we have to take that. Okay, now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.